Hey guys, welcome to Ace Hub AI.
So hi everyone, today I'll be giving you an introduction of our project which is text to speech. All of you must have used the Google Translator sometime or the another, but have you given an input as a mathematical formula? I guess not. So that's what we'll be doing today. I have chosen the Pythagoras theorem as the input and I want you all to listen to how the speech is generated there. So this is the input as you can see. Now listen to the output.
Hi, the Pythagoras theorem is a squared equals b squared c squared.
So this is the basic example of what a text-to-speech model is. And if you listen to the output correctly, you must have heard that omitted out the addition operator here. It simply said b squared c squared. So that is what our motive is. We develop a text-to-speech model such that it can process mathematical formula, images and code snippets effortlessly. Now, let us look at the technology used. The basic programming language for machine learning, which is Python. For frameworks, we have used PyTorch, which is the most popular deep learning framework right now. And even our models, like if we see this one, the Google T5 small, you can see PyTorch here, right? Where my cursor is. So next we have Jupyter notebooks for as an IDE for writing our code. For text generation model, we have used the T5 small, which you can see right here is text to text. Next, we have used the speech generation model, which is Google TTS, which is text to speech. So the main idea is that the output from this model, which is the T5 small, would be a text to text, and this text would then go into our text to speech model, which is Google TTS, and in the end, we would have clear speech. Now the question arises, why did we choose T5 when other models like BERT, GPT-4 exist, or we can simply fine-tune the existing Tortoise CTS to our needs? So talking about Tortoise CTS, Tortoise CTS has a few drawbacks, some major ones. Firstly, we would need batch processing and it is very GPU intensive. Secondly, if we look at the architecture of Tortoise TTS, we can see that actually the model was made using five separately trained neural networks, right? Pipelined together to produce the final output. So to fine tune this, you can imagine how difficult it would be. Secondly, if while the model was being made, uh, the the creator of the model thought that it was best to use a standard encoder decoder architecture, which is usually used in all text to text models, but he ran into some problems which made him make the model with only a decoder only architecture, which is not feasible for the function we want to serve, right? So we need an encoder too. So that's why we decided not to go with tortoise. Secondly, we could also use BERT, but it also has some disadvantages. Talking about the disadvantages of BERT, right? So here, if you see, this is the Hugging Face platform where we can search for any model. So if you look here, that the BERT model usually encodes or I would say masks a certain part of the input text only. Like if you can see, taking a sentence, the model randomly masks 15% of the words in the input. Now imagine we have a very large paragraph. So it only masks 15% of the words. So that is not feasible, right? And secondly, our purpose is text generation. Now, if you see in the limitations of this model, For tasks such as text generation, you should look at model like GPT. So this model is not this model cannot be used for text generation. You can also see in the tags here, there is no text generation. Talking about GPT-4, it would be the best choice, but we don't have access to it yet. So we decided to go with T5, right? Now I'll show you the things about T5. This is the total T5. So firstly, text-to-text generation, it can do. Secondly, this is the key difference between T5 and BERT, is that BERT only labels or masks a span of the input, but T5 takes the complete input and it can perform any NLP tasks which takes into account text generation, right? Now, this is the project overview, is that we will use the T5, which is text to text transfer transformer model, to perform text manipulations like text pre-processing, removing the formulas, the unwanted characters, and producing a refined output that would go into our text to speech model or the Google text to speech library here. Next, the main objectives were text cleaning, is that we remove special characters like from the mathematical formulas and images, image extensions. Secondly, text generation. Now this clean text would then be fed into our T5 model, which will generate meaningful text outputs. And then these text outputs would then go into the RGTTS, which will convert the text into high quality audio, and then the user interaction, in which the user can listen to the audio generated and interact with it. Now, a huge part of this was the data collection for training our T5, or I would say fine tuning our T5 model. Data collection was a bit difficult, but we managed to do it with the help of GPT. So we have three kinds of data: training data, validation data, and test data. So the model was obviously trained on the training data, which contained around like 1000 or 1100 samples. Um, the size will depend on the complexity of the task and the diversity of text inputs. Next, the validation data was used to check if the model is generalizing well on unseen data. And the last was a test data in which we were checking the quality of outputs from the T5. And we were using the GTTS to convert those outputs to speech. Yeah, that's it. Thank you.
Thanks for watching. If you enjoyed the content, please like, share, and subscribe to our channel. And remember, ace the AI race with Ace Hub. See you in the next video.